Meanwhile, Chinese developers have released a video showcasing one of the most advanced humanoid robot manufacturing factories, demonstrating what the real heart of the robotics industry looks like today. The footage shows automated assembly lines, precision tuning zones, testing rigs, and quality control systems where each robot undergoes multi-stage inspection before entering mass production. This center was created not just for assembly, but for a full development cycle. Prototypes are refined, designs optimized, software tested, and mass production processes perfected. Special attention is given to joint precision, movement balance, and electronics reliability, the very elements that make humanoids suitable for real-world work. All of this shows that China is moving from experimentation to industrial scale in robotics and is steadily approaching the mass deployment of humanoid machines in the real economy. Figure AI robots, thanks to the new Helix 02 tactile system, are now capable not just of seeing and moving, but truly feeling the physical world. In a recent demonstration, the company showed a humanoid robot performing delicate manipulations that were previously considered impossible without human involvement. Unscrewing bottle caps, carefully extracting pills from organizers, precisely measuring liquids, and handling small objects without errors or slips. The key element of Helix 02 is the high-precision tactile sensors embedded in the robot's fingers and palms. These sensors measure pressure, contact, micro-movements, and object resistance in real time, allowing the system to understand exactly how an object feels in the hand. Unlike traditional approaches, where the robot relies almost entirely on vision, Helix 02 integrates touch, vision, and AI control models, creating a full-fledged sense of touch. Boston Dynamics, in collaboration with RAI Institute, released a new video demonstrating the extreme capabilities of the humanoid robot Atlas. In the footage, engineers test full-body control and mobility in dynamic movements, jumps, acrobatic maneuvers, and sharp actions with phases of full airborne motion. Atlas executes complex movement sequences while maintaining balance during takeoff, in the air, and upon landing, requiring precise calculation of trajectory, body orientation, and synchronized joint movement before touching the ground. These tests showcase advances in control algorithms and learning, allowing the robot to adapt to loads in real time without teleoperation. In addition to advanced acrobatics, Atlas demonstrates stable running with natural leg and torso motion, rapid weight transfer, and precise balance control at speed. In China, the first AI humanoid police robot has also officially begun service on city streets, helping regulate traffic and interact with road users at busy intersections. This robot, known as Intelligent Police Unit R001, was deployed on one of the central streets of the city of Wuhu in Anhui Province in early January. It stands on a traffic island, dressed in a police uniform with a vest and a white peaked cap, and at first glance can easily be mistaken for a real law enforcement officer. In reality, it is a high-tech automated assistant equipped with artificial intelligence, a high-definition camera, and a speech system, which automatically detects traffic violations, such as cyclists riding outside designated lanes, and issues audible warnings to road users. The robot is integrated with city traffic signaling and control systems, allowing it to synchronize its gestures, voice messages, and movements with traffic light changes, as well as autonomously move to assigned locations on command. Moving on to other robotics news. In China, the fastest humanoid robot to date has been unveiled, called Bolt, and it has already set a record that could change perceptions of humanoid machines and their real-world mobility. Bolt is a full-size humanoid robot created by the Chinese company MirrorMe Technology in collaboration with the Humanoid Robot Institute at Zhejiang University. It stands about 1.75 meters tall and weighs approximately 75 kilograms, meaning its size and proportions are almost identical to those of an adult human. What truly makes Bolt special is its locomotion capability. During real-world tests, the robot reached a speed of up to 10 meters per second, which is roughly equivalent to 36 kilometers per hour, and this is considered the highest speed ever recorded among full-size humanoid robots in history. The Shanghai-based startup Qingbao Robot has demonstrated progress in developing realistic humanoids, aiming to bring them as close as possible to the human image, not only visually, but also in behavior, facial expression, and interaction with people. In its latest demonstrations, Qingbao Robot presented humanoid robots with an extremely high level of visual realism. Special emphasis is placed on the face, skin with a texture close to human, natural proportions, refined features, as well as smooth operation of the eyes, lips, and eyelids. Facial expression has become the key element, with robots capable of reproducing subtle emotional reactions that were previously inaccessible to most humanoid platforms. Technologically, such humanoids use complex systems of micro-actuators placed in the face and neck area, allowing the transmission of micro-expressions, slight lip tension, changes in gaze, barely noticeable eyebrow movements. Combined with AI algorithms for speech and context recognition, this creates an effect of living presence, especially during one-on-one interaction. Another human-like robot from Xpeng is increasingly approaching realism and movements that replicate human gait with striking accuracy. We are talking about the humanoid iron, which is already considered one of the most lifelike robots in the world today. During presentations, iron moves so smoothly and naturally that many viewers initially think they are seeing an ordinary person. Its steps, body posture, arm movements, and even micro-motions look as natural as possible, without abrupt jerks or stereotypical robotic mechanics. Engineers achieved this effect thanks to a bionic body design, a flexible artificial spine, artificial muscles, and dozens of degrees of freedom in the joints. The robot constantly analyzes the surface beneath its feet, redistributes weight, and adjusts balance in real time, almost the same way the human brain does. Iron's height is about 1.7 meters. Its weight is approximately 70 kilograms, meaning its proportions are as close to human as possible. Inside, a powerful artificial intelligence system runs on Xpeng's own chips, integrating vision, spatial perception, and motion control into a single system. Before you is the new realistic humanoid robot Moya from the Chinese company DroidUp, which is already sparking intense discussion in the world of robotics thanks to its strikingly human appearance, facial expressions, and behavior. Moya was officially unveiled in Shanghai in early 2026 as the world's first fully biomimetic robot with embodied artificial intelligence. This means the machine does not simply run on algorithms, but attempts to perceive the surrounding world, interact with people, and express emotions, not through a screen, but through its own body and movements. One of Moya's key features is the imitation of human behavioral traits and sensations. The robot can maintain eye contact, smile, nod, and reproduce subtle micro-expressions thanks to a system of up to 25 adjustable actuators in the head, capable of modeling facial expressions almost like those of a living person. Its walking is also distinguished by realism. DroidUp claims that Moya moves with 92% accuracy relative to a human gait, something that even the most advanced humanoid platforms have so far rarely managed to achieve. In technology circles, on closed forums, and among venture investors, discussions have been ongoing for several months about the fact that Apple, one of the most closed and cautious companies in the world, has begun work on a completely new project, namely, the development of its own line of humanoid robots, which would represent the company's most large-scale move beyond its familiar product lineup in recent decades. According to several insiders familiar with the situation at the top management level, Apple has indeed initiated the so-called Titan 2.0 project, which is formally unrelated to automotive development and instead represents an attempt to create a physical device capable of operating alongside humans, assisting users with tasks, and integrating with the Apple Intelligence ecosystem. According to sources from Financial Times and The Verge, details of this project are under the strictest secrecy, but its existence has already been confirmed by several contractors involved in the preliminary stages of development. What makes this rumor particularly resonant is that the robot concept at Apple, according to these sources, is not a classic copy of existing humanoids like Tesla Optimus or Boston Dynamics Atlas, but rather a proprietary interpretation of the idea, a minimalist, fluid body with an emphasis on expressive design, lifelike sensations, and smooth movements, fully aligned with Apple's aesthetics and product philosophy. While, according to Bloomberg, the company aims to make it not just a machine with limbs, but a device with deep AI integration, capable of understanding the context of the owner's actions, predicting needs, and interacting with the environment at the level of an entirely new user experience. This year, insiders claim, Apple plans to organize its first closed demonstration of a prototype, possibly even at one of the major industry exhibitions, which, if confirmed, would be an unprecedented step for a company that has never before shown working robotic systems to the public. Most intriguing is the fact that similar information has already surfaced in reports by Nikkei Asia and Reuters, based on conversations with component suppliers, who claim that Apple has increased orders for specialized servos, motion sensors, and compact neural network modules that are used specifically in robotic systems rather than in smartphones or wearable gadgets, indirectly confirming work on a project that goes beyond the scope of Apple's traditional devices. According to experts from MIT Technology Review, if Apple truly succeeds in creating such a robot, it could radically change the landscape of the personal robotics market, because until now, almost all attempts by major technology companies to create humanoid robots have been either niche or experimental, whereas Apple's presence in this field would guarantee an influx of capital, engineering resources, marketing power, and, no less importantly, a ready-made services ecosystem and user base capable of adopting such a product. And this, in turn, has led to scenarios already being considered in strategic reports by Goldman Sachs and JP Morgan, in which Apple could shift the paradigm of human-machine interaction by moving the focus away from screens toward a physical device capable of literally living alongside the user, helping with everyday tasks, smart home management, work, and even emotional support. This is precisely these aspects that, according to analysts, make the project a potentially dangerous competitor to companies such as Tesla, Boston Dynamics, Agility Robotics, and other players that have been investing in autonomous robots for decades but have so far failed to bring commercial models to the mass market. And although there are still no official statements from the company itself, and Apple representatives consistently avoid commenting on the topic, stating that they do not comment on rumors and speculation, for the industry, this project has already become one of the biggest intrigues of the coming years, capable, if realized, of rewriting the rules of the game in the market for personal devices, AI assistants, and robotics as a whole. China has once again shown what the future looks like, and this time it was not on laboratory test benches or in closed demonstration halls for investors. In 2026, the country hosted the world's first large-scale robot gala concert, Agrabot Night, a show where not a single human appeared on stage. Dancing, music, theatrical scenes, and synchronized performances were carried out entirely by humanoid robots controlled by artificial intelligence. This was not just an attraction for spectators, but a demonstration of a new level of robotics maturity, movement coordination, autonomy, teamwork, and real-time interaction with the environment. What only a few years ago seemed like an experimental concept for exhibitions and internet videos is now turning into a full-fledged entertainment industry, where robots take the stage as independent performers. Most importantly, behind this spectacle lies not just impressive visuals, but a real technological leap by China in humanoid robotics, AI-based motion control, synchronization, and mass production of such systems. In this video, we will break down how this show was created, what technologies stand behind it, how autonomous these robots truly are, and why projects like this are not merely entertainment, but a direct statement of China's ambition to lead the new robotic era. One of the most viral moments of Agrabot Night 2026 was the performance of a humanoid robot singer in the guise of a fantasy character. Essentially, This was no longer just a mechanical puppet on stage, but a fully realized digital physical performer. The audience saw a next-generation humanoid robot combining a mechatronic body, an AI-based voice synthesis system, and a neural network model for vocal performance capable of adapting to a live orchestra and the acoustics of the hall. The robot did not simply play a pre-recorded track. The system adjusted tempo, volume, and emotional accents in real time according to the music and audience reactions. A key technological aspect was the control of facial expressions, gestures, and micro head movements synchronized with the vocals, creating the effect of the presence of a real performer rather than an automated demonstration. Essentially, the stage showcased a prototype for the future industry of digital performers, where AI artists could perform in concerts, theaters, and shows without human involvement, scalable to any venue or format. For China, this is not just show content, but a test of a commercial model for future virtual physical artists capable of working 24/7, touring without fatigue, and becoming a separate segment of the entertainment market based on AI and humanoid platforms. In one of the most striking numbers of Acrobat Night 2026, robots took the stage alongside live ballerinas, demonstrating not just a spectacular show, but the integration of AI into complex choreography with humans. This performance featured Acrobat A2 humanoid robots from the Chinese company Acrobat Robotics, as well as mobile robot platforms designed for stage productions and service tasks. The robots moved synchronously to the music, maintained balance during sharp turns, precisely replicated elements of classical ballet, and simultaneously tracked the positions of nearby humans to maintain distance and ensure safety. The key technology here was computer vision and a real-time human motion trajectory prediction system. The robots understood where the performers were and adjusted their gestures, speed, and movement amplitude to match the live dancers. Essentially, this was a public test of safe humanoid-human interaction in a dynamic environment, a capability directly transferable to future service robots in shopping centers, airports, hotels, and mass events. China used the stage as a showcase not only for visual wow effects, but also for applied technologies in collective AI and real-time human-robot safety interaction. On the stage of Acrobat Night 2026 in China, humanoid robots Acrobat A2 performed. Production models developed by the Chinese company Acrobat Robotics, one of the fastest-growing players in the humanoid platform market in Asia. These robots were not created as show toys, but as universal mobile systems designed for work in services, logistics, warehouses, and commercial spaces. The concert used them as a public demonstration of real capabilities, synchronized dancing, complex motion coordination, balance retention during sharp turns, and operation in dense groups without collisions. The key technology here is distributed AI control. Each robot makes local movement decisions, while a central system synchronizes tempo, rhythm, and positioning of the entire group on stage in real time. In essence, this is a live stress test of the same algorithms that will later be used for collective humanoid robot work in factories, logistics hubs, and retail spaces. Acrobat demonstrated that China has already reached a stage where humanoid robots are not exhibition prototypes, but scalable platforms that can be trained, updated via software, and deployed at scale across the economy, with the concert serving as a striking showcase of this technological shift. In this neon performance at Acrobat Night 2026, the stage showcased multiple directions of modern robotics in a single act: next-generation humanoid robots, mobile platforms, and biomorphic robots mimicking the movements of animals and fantastical creatures. This was not just a visual spectacle with lighting. Algorithms for stability, coordination in low-visibility conditions, and motion synchronization under complex lighting scenarios were being tested. The robots operated in complete darkness, navigating using LiDAR, inertial sensors, and computer vision that adapts to sudden light flashes and changes in color temperature. For engineers, such performances serve as a stress test. The stage simulates a chaotic environment with interference, reflections, and moving objects, closely resembling real conditions in warehouses, show venues, and public spaces. At the same time, the modularity of the platforms was demonstrated. The same base robots were fitted with stage skins featuring neon lighting and electronics protection, showing how humanoids and mobile robots can be quickly adapted for different industries, from entertainment to patrolling and event services. Essentially, this act served as a visual showcase of how China tests robots not in sterile laboratories, but in conditions as close as possible to real-world operation. The role of host at Acrobot Night 2026 was taken by a humanoid robot presenter from Robotics, essentially a demonstration of how AI is moving beyond dancing robots and beginning to take on functions of hosts, assistants, and public interfaces between technology and humans. This robot is controlled by a combination of a speech model, speech recognition system, and gesture synchronization module, allowing it not just to read text, but to react to applause, pauses in the audience, and the pace of the show. Special emphasis is placed on visual communication. Hand movements, torso turns, and facial light expressions are synchronized with speech, creating the effect of a live host rather than an automated announcer. In practice, this demonstrates a real-world application. Such humanoids are already being tested as administrators at exhibitions, shopping centers, and conferences, where it is important to engage in dialogue with people, explain products, and guide visitor flows. China is showing that humanoid robots are entering the stage of public AI interfaces. They are becoming the face of technology at mass events, and shows like this are not just entertainment for likes, but real-world testing of commercial scenarios for the service robotics industry. In one of the most symbolic acts of Acrobot Night 2026, robots in the form of pandas appeared on stage alongside children, and behind the external cuteness lies an important demonstration of human-centered robotics technologies. These robots are service mobile platforms from Chinese manufacturers, adapted for interactive shows and educational scenarios. They moved alongside children, responded to gestures, maintained a safe distance, and performed synchronized actions without rigid movement scripts. The key element is the safety system, recognition of people, prediction of a child's movement trajectory, and instant stop in case of sudden approach. Essentially, this was a public test of how robots can safely operate in spaces with children, in museums, educational centers, amusement parks, and shopping complexes. Equally important is that such acts are not only shows, but also a psychological adaptation for the audience. Children become accustomed from an early age to interacting with robots as a normal part of their environment. China is testing scenarios for a future where robots will be part of everyday urban infrastructure, not as metal machines, but in friendly forms designed for safe interaction with people. A next-generation home cleaning robot was presented by Roborock engineers, the Saros Rover model, which radically changes the idea of what household vacuum robots can do. Unlike classic round robots, Saros Rover features a unique design with two movable wheeled legs that can independently raise, lower, and change their angle. In demonstrations, the device showed how it can autonomously climb and descend stairs, overcome high thresholds, uneven surfaces, and complex height differences while continuing to clean at the same time. The robot literally steps over stairs, cleaning each step, and then smoothly transitions to the next area. Saros Rover analyzes its surroundings in real time, maintains balance on inclined surfaces, avoids obstacles, and can perform small lifts to overcome difficult sections. While the exact release date and price have not yet been announced, the concept already demonstrates the future of robotic cleaning. Meet a new humanoid robot from the Italian company Generative Bionics called Gene 01, first shown to the general public at CES 2026 in Las Vegas. This is not just another experimental robot, but an entirely new platform that defines the DNA of future generations of autonomous humanoids, with a focus on tactile perception and physical artificial intelligence. The key feature of Gene 01 is an integrated full-body tactile skin made up of a distributed network of touch and force sensors that allows the robot not only to see and hear, but also to feel touch, pressure, and micro-interactions across its entire body. This data is used not only for safety, but as a full-fledged perception channel, making interaction with people and objects far more natural and safe. In recent months, a scenario has been increasingly surfacing in Asian tech circles that until recently seemed geopolitically impossible, but is now being actively discussed among supply chain insiders and telecom analysts. Xiaomi is allegedly exploring options to integrate next-generation satellite internet into its future smartphones and ecosystem devices, viewing partnership with SpaceX as a technological reference point rather than a guaranteed path. Sources close to discussions within the Chinese industry claim that Xiaomi laboratories have been testing prototypes with direct satellite connectivity for several years already, as the company understands that the next phase of competition in the smartphone market will be driven not by cameras or displays, but by the ability to stay connected anywhere in the world without dependence on mobile operators. At the same time, insiders stress that a direct partnership with SpaceX and the Starlink system remains an extremely sensitive issue, since Chinese regulators and cybersecurity authorities are unlikely to approve mass integration of an American satellite network into devices sold inside China and in strategically important markets. According to analysts, Xiaomi is considering a dual-track scenario. For global markets, the company could theoretically use technologies compatible with the Starlink direct-to-cell architecture, while for the domestic Chinese market and countries aligned with Beijing, an alternative local satellite provider would be used. Sources say that projects linked to state-backed satellite constellations and private aerospace startups, which are rapidly developing their own low Earth orbit satellite communication systems with government support, are being considered as potential Chinese equivalents of SpaceX. Experts note that Beijing is highly interested in creating a fully sovereign alternative to Starlink, as dependence on foreign communications infrastructure is viewed as a direct threat to national security. For this reason, according to insiders, the fate of such a Xiaomi project depends directly on the stance of Chinese authorities. If regulators see it as a tool of technological superiority and export influence, the project will receive approval, but if it is deemed a risk to digital sovereignty, any partnership with SpaceX will be blocked at an early stage. Analysts emphasize that the stakes for Xiaomi are enormous. Integrating satellite internet into smartphones could give the company a powerful competitive advantage in developing markets, where mobile infrastructure is weak and access to connectivity remains a challenge. At the same time, the need to balance global technologies with the requirements of the Chinese state makes Xiaomi's strategy far more complex than that of Samsung or Apple. According to industry sources, the company is already discussing a model in which users of global Xiaomi device versions would receive basic satellite access for messaging, navigation, and emergency communication, while for China, a separate satellite connectivity ecosystem based on national projects would be developed, effectively creating two parallel technological worlds within a single brand. Experts believe that if Xiaomi manages to implement such a dual-layer strategy, it will become one of the clearest examples of how geopolitics directly shapes consumer technology, and how the fate of satellite internet in smartphones will be decided not only by engineers and business leaders, but also in government offices. Another unique device was presented by Momax, a smart ring called Momax OneSense Soul, which combines everything needed for comprehensive health and lifestyle tracking in an ultra-compact format. It is not just a fitness tracker for the finger. It is designed to help you understand your body more deeply and accurately than most wearable gadgets. The ring is equipped with advanced sensors that continuously monitor heart rate variability, blood oxygen levels, and skin temperature, as well as track movement data, steps, calories, and daily activity. In addition, the device offers sleep analysis, wake periods, and breathing metrics, allowing you not only to view the data, but also to receive personalized recommendations to improve rest and recovery. Momax OneSense Soul is very lightweight and waterproof, made of durable composite material and stainless steel, weighing only about 4 to 4.5 grams and able to withstand immersion up to 50 meters. The battery lasts up to approximately 6 days of use, and data can be stored offline for up to 7 days if the ring is temporarily not connected to a smartphone. Motorola unveiled the world's first flexible smartphone, presenting a concept device of a new form factor that can not only fold but also physically bend, taking different shapes depending on the usage scenario. Unlike traditional foldable models, this smartphone uses a continuous flexible POLED display capable of functioning as a classic phone, a curved screen for content viewing, or even as a wearable device on the wrist. The device features a large, flexible 6.9-inch screen that dynamically adapts the interface to the shape of the body. The software shell automatically rearranges controls, notifications, and widgets to match how the user bends the device. When the screen is bent, widgets can turn into compact information panels, quick controls for music, navigation, messages, or fitness data, and when fully unfolded, into full interactive blocks. Chinese startup Acrobot announced Q1, a compact AI-powered robot small enough to fit in a backpack. Q1 stands just 80 centimeters tall and weighs roughly 8 times less than full-sized humanoids. Despite its miniature size, it features a full-body control system, including precise management of force and balance. The robot can walk confidently, turn, squat, stand up after falls, perform complex poses, and execute dynamic movements while maintaining stability even under external forces. Q1 is equipped with a full-body quasi-direct drive system for joint and force control. According to Acrobot, the reduced weight increases the robot's collision resilience and lowers modification costs during testing. Pricing and release date for Q1 have not yet been announced. Anchor Nebula introduced a portable mini-cinema in the form of a capsule. Capsule Air is an ultra-compact portable projector that can turn any wall or surface into a screen for movies, games, and streaming content. The device, roughly the size of a drink can, features a built-in Google TV system, allowing users to watch favorite films and series directly without extra set-top boxes or cables. Nebula Capsule Air uses DLP projection technology with HD resolution and around 150 lumens brightness, providing a clear image in moderately dim conditions. It supports autofocus and automatic keystone correction, simplifying screen setup in any environment. The projector weighs about 0.65 kilograms and has a built-in battery that provides up to 2 hours of operation, enough to watch a full movie or several episodes of a series away from a power source. Moving on to other news, InMotion has unveiled the InMotion P6, one of the most powerful and technologically advanced electric unicycles in the world, designed for experienced riders and fans of extreme speed. The model is built on a high-voltage 235-volt platform and delivers peak power of up to 20,000 watts, allowing it to accelerate to nearly 150 kilometers per hour, a figure unattainable for most personal transport vehicles. Range is handled by a battery with a capacity of around 4,200 watt-hours using Samsung cells, providing up to 150 kilometers of range, while fast charging support allows most of the energy to be replenished in just 1 hour. For comfort and stability, the P6 features a hydraulic suspension with about 90 millimeters of travel, effectively smoothing out bumps even at high speed. The device weighs over 50 kilograms, emphasizing its focus on professional use. Engineers at Humanoid have introduced a new intelligent platform called KinetIQ, a kind of brain for humanoid robots that allows them to perceive the surrounding world, understand tasks, independently make decisions, and precisely control their movements in real time. This system combines vision, language, analytics, and physical control into a unified architecture, enabling robots to move beyond being merely pre-programmed machines and begin acting in a more aware and flexible manner. At the core of KinetIQ is a multi-layer control model. At the top level, it distributes tasks among robots and coordinates their work. At the middle level, it transforms goals into concrete actions. And at the lower level, it is responsible for balance, joint coordination, and full body stability. The platform integrates vision-language action technologies that link visual perception, voice commands, and physical actions, allowing the robot to understand a human and immediately translate words into movements. In addition, the system supports collective learning. Each robot transmits its experience to a shared network, enabling the entire ecosystem to continuously evolve and become smarter. Engineers at Spirit AI unveiled Moz 1, a humanoid robot assistant, a high-performance platform designed not just as a demo prototype, but for real-world applications in industry, service, and education. The robot combines advanced mechanics, intelligence, and the ability to understand and execute complex multi-step tasks in dynamic environments. Moz 1 features 26 degrees of freedom and full force control in all major joints, allowing it to manipulate objects precisely, adapt to shape, texture, and position, and perform tasks requiring high accuracy and adaptability, such as folding clothes, servicing objects, or completing multi-step instructions. It can handle soft items carefully, move objects of various shapes and weights, and navigate and adjust to changing environmental conditions. We move on to robotics news. The world-famous company Unitree Robotics has published a video showing its humanoid robot G1 operating in extremely cold conditions, down to -47.4 degrees Celsius, and completing a large-scale autonomous test that became the world's first such challenge for a bipedal robot at these temperatures. In the video, the G1 robot developed by the Chinese company Unitree walked through deep snow in northwestern China in the Altai region, where air temperatures dropped to -47.4 degrees Celsius. Over the course of the test, it completed more than 130,000 steps, demonstrating stable autonomous locomotion in extreme cold. During the trial, the robot even traced a large outline of the Winter Olympics emblem in the snow, measuring approximately 186 by 100 meters, showcasing not only its ability to move, but also to carry out assigned tasks on a challenging surface. Meet the new full-size humanoid robot L7 from Roboterra, which combines high speed, powerful strength, and advanced intelligence. L7 is a full-size two-legged robot standing about 171 centimeters tall and weighing approximately 65 kilograms, equipped with 55 degrees of freedom, giving it incredible mobility and the ability to perform both large movements and fine manipulations. One of the robot's key features is its physical dynamics. L7 can run at speeds up to 14.4 kilometers per hour, making it one of the fastest humanoids today, and can perform 360-degree rotations, dynamic jumps, and complex acrobatic maneuvers. But L7 is not just about speed. The robot is equipped with high-torque actuators of up to 400 Newton-meters and can lift and carry loads up to 20 kilograms with both hands, making it potentially useful in logistics, industry, and service applications. In recent months, the same phrase has been increasingly heard within the tech industry, whispered at closed conferences, in the corridors of presentations, and during private investor meetings in San Francisco and London. Apple is preparing not just a new product, but a paradigm shift capable of overturning the very idea of what a personal gadget should be in the age of artificial intelligence. And according to multiple sources close to the company's supply chain, Apple has been developing for several quarters an entirely new class of device that does not fit into the iPhone lineup or the Mac or iPad ecosystem, but instead represents an attempt to create a physical carrier for AI that is not tied to the smartphone as a central hub. This move, according to analysts at Bloomberg and the Financial Times, could become Apple's most risky yet most ambitious decision since the launch of the first iPhone, because the company is effectively acknowledging that the era in which the smartphone is the main center of a person's digital life is gradually reaching its limit, and the future will be distributed, contextual, and built around an AI assistant that is constantly near the user, hears them, understands the surrounding context, is integrated into the home, car, workspace, and wearables, and does not require constant attention to a screen as is the case today with the iPhone. According to insiders at Asian contract manufacturers, Apple has already ordered test batches of next-generation microphones, energy-efficient processors optimized for local neural inference, and compact high-density batteries, which indicates this is not merely a concept, but real prototypes going through early validation stages. And supply chain sources claim the project operates under an internal codename not directly related to iPhone or Vision Pro, which in itself signals the creation of a new product category. According to the Information and Nikkei Asia, Apple views this device not as another iPhone accessory, but as an independent entry point into the Apple Intelligence ecosystem, which is expected to become the central pillar of the company's AI strategy in the coming years. And it is here that the most unexpected and at the same time most resonant element of the story appears, as several sources familiar with top-level executive discussions say Apple is indeed holding closed negotiations about a technological partnership with Google in the area of infrastructure and AI models, which sounds almost shocking given the company's long-standing rivalry, but in reality fits into a broader picture of geopolitical and technological pressure in the AI market, where the US, China, and major corporations have entered a phase of intense competition for control over the future platform of human-AI interaction. And whereas Apple previously relied on proprietary solutions and maximum independence, according to the Wall Street Journal, a more pragmatic argument is now increasingly voiced inside the company that in the race for a universal personal AI assistant, it is impossible to remain confined to a single ecosystem without limiting scale and speed of development, which is why a model of limited partnership with Google in cloud infrastructure and certain foundational AI models is being considered, while Apple retains control over the user interface, privacy, and hardware, effectively creating a hybrid model where an external partner provides the brain and Apple provides the body and senses. In the view of Morgan Stanley, analysts, such an alliance could become a strategic response not only to Samsung and Huawei, which are rapidly expanding their own AI ecosystems, but also to players like OpenAI that are attempting to move beyond software into the market of physical devices by creating next-generation AI gadgets. In this context, Apple's new device looks like a preemptive strike against a potential threat from startups and technology giants attempting to seize control over the user's entry point into the world of AI. Because whoever controls the device through which a person interacts with artificial intelligence also controls the user's behavior model, habits, data, service ecosystem, and ultimately financial flows. And that is precisely why inside Apple, according to sources from the Cupertino headquarters, the new device is viewed not as an experimental accessory, but as a strategic element that over a 5 to 7 year horizon could become as significant as the iPhone was in 2007. And while officially the company continues to speak about developing the iPhone as the center of the ecosystem, within product teams the idea is increasingly voiced that future AI devices will be less visual and more contextual, that people will take smartphones out of their pockets less often and interact with AI more frequently through voice, gestures, and the surrounding environment. This is exactly for this paradigm that the new gadget is being designed, which, according to insiders, may take the form of a small physical object constantly near the user and connected to the Apple ecosystem, with a key emphasis on privacy and local data processing, serving as a direct response to user and regulatory concerns about total data collection by AI services. And in this sense, Apple is trying to position itself as an ethical intermediary between humans and AI, contrasting itself both with Chinese manufacturers accused in the West of close ties to state structures and with American startups criticized for aggressive data monetization. And against this backdrop, tech media increasingly suggest that we are on the verge of a new ecosystem war, where what is at stake is not just the smartphone or smartwatch market, but the very architecture of future digital interaction between humans and the world. If Apple does bring a new class of AI devices to market, it will force Samsung to accelerate its development of personal AI assistants, Huawei to more aggressively promote its own alternatives in Asia and the Middle East, and OpenAI to move even faster toward hardware solutions so as not to end up in a situation where access to its models is controlled by third-party platforms. According to Goldman Sachs analysts, the fight for the physical carrier of AI will become the main competitive battlefield over the next 10 years because software can be copied, models can be improved or replaced, but the device a person carries every day shapes habits and loyalty. And if Apple manages to be the first to create a mass-market AI gadget not tied to a smartphone, it could radically alter the balance of power, transforming the company from a device manufacturer into an operator of a person's personal AI space. That is why rumors of a partnership with Google are perceived not as a sign of Apple's weakness, but as evidence that the company is willing to make temporary compromises for strategic advantage in a long-term game. And if sources in business circles are to be believed, the first closed demonstrations of prototypes have already taken place for a narrow circle of top executives and investors. While a public announcement of the concept of a new class of devices could occur within the next couple of years, after which the market will see whether Apple is truly ready to take its most risky step in decades and move beyond an iPhone-centric philosophy, challenging not only Samsung and Huawei, but also the very architects of the modern AI world, such as OpenAI, in the battle to become the primary intermediary between humans and artificial intelligence in an era that is only just beginning. If these forecasts are confirmed, the launch of Apple's new device could mark the beginning of a new consolidation phase in the AI device market, where a handful of giants set the rules of the game, and everyone else must either adapt to their ecosystems or exit the market altogether.